We kind of have a running joke around here that someone's always claiming cosmology is in crisis. While I don't subscribe to that kind of clickbait alarmism, it is true that we're constantly making new discoveries that challenge our understanding of the universe. JWST has done an amazing job of discovering objects in the early universe that are very different to what we expected to find. As you've probably guessed by now, JWST and a team of scientists from the University of Missouri have done it again. This time, astronomers have used JWST's MIRI and NIRCam infrared instruments to find around 300 objects in the very early universe that are suspected to be galaxies. The problem with these galaxies is that they are much brighter than we expect them to be, given what we think was happening during the early stages of the universe. Previously, astronomers have assumed that these types of brighter than expected objects were something unidentified and not galaxies, but this new research suggests they could be wrong, and actually they are galaxies after all. Let's dig into the physics here just a little bit. The light from objects in the early universe has been traveling to us for a very long time, and in that time, the universe has expanded, causing the light to be shifted to redder wavelengths. Since we're not very imaginative, we call this effect cosmological redshift, and in some cases, it shifts light all the way from the visible part of the spectrum to the infrared. There are other types of redshift, but cosmological redshift is the one we're interested in here. By selecting objects that appear in the redder part of the spectrum but don't show up at the bluer end, the research team was able to use JWST to find the 300 candidate objects and confidently say that they're located somewhere in the early universe. Determining exactly how far back in the early universe these objects are located poses a challenge that's normally solved by looking at the spectrum of an object across a range of wavelengths and seeing how far the wavelength of known features in the spectrum has been redshifted. That shift gives us the distance to the object, or equivalently, how far back in time it exists. For just one of these objects, spectra do exist and confirm that it is a galaxy. For the other few hundred cases, the team used a kind of shorthand method that doesn't require full spectroscopy but is less accurate. In order to confirm that these objects are indeed galaxies, full spectra will be needed for at least a significant fraction, and getting the data is next on the astronomers' to-do list. If they turn out to be bright galaxies in the early universe, our models of galaxy formation will have a lot of explaining to do, and it'll be yet another challenge for our understanding of cosmology. That's how science works, though. We come up with theories, and then we test them against the physical world, and then we adjust our theories and test again. This is a feature, not a bug, and if we aren't finding surprising results now and then, we've probably stopped learning anything new. The paper is published in the Astrophysical Journal. There's a link in the description along with a link to the press release from the University of Missouri. That's today's video. Please like and subscribe. I will catch you in the next one.